Hello guys, in this video I'm going to show you how to solve cycle in a circular array. So we're given an array containing positive and negative numbers, right? So here's an example. Negative with positive numbers in the arbitrary order, right? It is not sorted at all, right? So suppose the array contains number m at particular index, right? M could be any number here. Now, if m is positive, we move forward m indices. And if m is negative, we move backward m indices. So for example, if m is 1, we move forward one step, which means come to 2, right? If m is 2, we move forward 2 steps, 1, 2, another 2, right? So if m is minus 1, move backward one step, which means come back here, come to 2. Okay, next step, next line, you should assume that the array is circular, which means two things, right? So there are two conditions so that the arrays can be considered as a circular array, right? First, so if when moving forward we reach the end of the array, we will jump to the first element to continue the movement, right? So for example, we started 1, moving forward one step to 2. From 2, we move forward 2 steps, 1, 2. But we come to 2, this 2 means we move forward 2 steps, but it will be out of range, right? So as we reach the end of the array, here we will come back to the first element to continue movement, right? So from here, first step would be go to the last element. The second step would be come back to the one, right? So basically what it means here, this line means, right? So if while moving backward, we reach the beginning of the array, we will jump to the last element to continue the movement. Do we have any example here? No, probably one, two. So for example, if this one is minus 2, for example, right? If we start at here, minus 2 mean moving backward 2 steps. 1, 2, we come to this minus 2. Again, backward 2 steps. The first step would be coming to this 2, right? The second step would be go back to the last element to minus 2 here, right? So basically what it means for this side. So right method to determine if the array has a cycle, right? So okay, just reverse back here. Okay, so here is a function we need to write. Each circular takes in an array. The cycle should have more than one element and should follow one direction, which means the cycle should not contain both forward and backward movements, right? So firstly, a method should, the cycle should have more than one element, right? So an invalid invalid array would be, this is an example. If we start at 3, right, mean moving forward 3 steps. So it would be 1, come back, 2, and 3. So after 3 steps, we're coming back to the number 3, which means our cycle has only one element. In that case, it would be invalid, right? So here would be something we need to consider also. Another thing would be it should follow one directions, which means the cycle should not contain both forward and backward movements. Let's look at this example. Like here, for example, if we start at -1, we will move backward 1 step, so come to 2, but we're expecting that it gonna keep uh, going backward and backward. But as we are reaching 2 here, it means we have to go to a reverse directions, right? So -1, it means we go to the left here, but come to 2, it means we must go forward 2 steps, right? So it would invalidate this line. So which means cycle should not contain both forward and backward movements, right? In this case, like if we consider the the cycle that started -1, for example, it would contain both forward and backward movements, right? So it, for those cases, we're just gonna consider it as an invalid. So there's a lot of information we need to consider here, right? So let's try to mark important points here, right? So what are the important points here? From my observations, here would be a conditions that we must include in our algorithm, right? Even though it's 2 lines, but the logic is the same here, right? The second thing would be this line. The cycle should have only one element. Here would be the second thing we need to consider. And here would be the last piece of information. Should follow one directions and means cycle should not contain both forward and backward movements. Okay. Okay, Slack. I think for this problem where there are a lot of informations, it's best to write down the layouts, right? For our functions first, right? Before going into details. So right? So, one observation that we can make here is that there could be different cycle, right? Different way to go. Uh, could be different, lots different multiple cycles in one array, right? So we must consider all those cycles. Um, we should consider all the possibilities, right? So what I means what I mean here is that we must uh, checking we must check if there is a cycle that starts at every number here, right? If there is a cycle that starts at 1, is a cycle that starts at 2, and so on, right? For every number. So let's write down. We must check if there is a cycle starting at every number, right? So what if we find the cycle that starts at one particular number? It means when I return choose for the whole functions, right? The requirement is that we find if there is a cycle in circular array, right? Uh, so it means if we can find at least one cycle, it means we can return true for the whole functions, right? At least one, so here at least one, return true, right? If we cannot find a cycle starting at one number, right? We can, if no cycle at current number, right? Now starting at current number, we just keep checking, right? So this suggests that we must use a loop here. Yes. Okay. So after going through this loop without returning true, it means we cannot find a cycle starting at every number. So it means we return false at the end. Okay, it's a solid foundations for our functions. The next step, which is very important, is to design the logic of determining whether there's a cycle starting at one number, right? So when talking about cycle, right, one common techniques we can instantly think of is to use uh, slow fast pointers. Basically, it means when I use two pointer uh, going at different speeds, right? The slow pointer will move one step forward and fast pointer move it two step forward, right? And if in the futures, at one point in the futures, two pointers meet at one point, it means there's an there's a cycle in our array, right? Uh, it is not only apply for linked list, right? But also in array also. So let's see how apply the slow fast pointer for array. Okay, so let's now for this array, right? I'm gonna use two pointers, slow and fast. Slow will be the current pointer, fast will be the dollar pointers, right? All starts at 1. Okay, so 1, the current number is 1, it means moving forward one step, right? So both will moving forward one step, but the fast pointer will will go at double speed, right? So the current is 2, so 2 step forward. Okay, 1, 2, okay, okay. Now slow will move forward. Current number is 2, 1, 2, and fast will be 1, come back, 2, but will move forward one more step, right? Because the current number is 1, 1. Okay, the slow will be 1, 2. Fast will be 1, 2. And 1, 2. Right. So as you can see, uh, the two pointers once again meet at one point, right? So it is how I wanna use two pointers for array to check if there's a cycle in an array, right? So same ideas as linked list, two pointers, slow and fast. But this one is more complex because we must consider uh, other edge cases as well. Uh, we must handle this logics, right? So if moving forward reach the end of the array, we will jump to the first element to continue movement. How I want to implement this? Actually, it's not very difficult because, for example, the current index 0, 1, 2, 4. Sorry. Okay. So, for example, let's look at only this pointer. Okay. So one step forward, go to 2, 2 step forward, go to 2 here, right? So we are now at index 3 and we must move forward 2 steps, right? So the next index would be 3 plus 2, it will be 5, would be out of range of this array. So in order to handle this case, we can use modulo operator here, right? Modulo of what? The size of the array, which is 5 here, right? So that it will be what is it here? It'll be 0, right? The remainder will be 0. So the next index would be at index 0, which is exactly what we need, because if we started this one, which means we move for 2 steps, 1 and 2, so coming back to index 0, right? So this is how we handle this logics of jumping back to the first element, and same for here as well. Okay, so the cycle should have only one element. How can we handle this one? So it means, so for example, like here, if we're starting at 3, so we can check, right, if the next index is equal to the current index. So the current index is, let's say, 0, 1, and 2. The current index is 1, right? So here we are at 3, moving for 3 steps, 1, 2, and 3. And as you can see, the current index is 1, the next index is also 1. So in that case, we have only one element in our cycle, so it will be not an terminal cycle, right? Now there is a cycle, say is a cycle, but it is not considered circular. Sorry. The logic here, right? We should follow one directions, right? Should follow one directions mean cycle should not contain both forward and backward movements. So how do we handle this? So one thing here is to just remember the current directions, right? So for example, if we start at 2, right? Let's say if we start at -1, for example, so our current direction would be right to the left, right? Moving backward, right? So we moving backward 1 step, we're still remembering the current backward directions, right? So we come to 2, as you can see, the number 2 means we must going forward, right? So as you can see, there are 2 directions here, right? The current directions, the original directions is moving backward, but the current number is 2 will have us moving forward, right? So which means this is not a circular array, right? Okay, so there are three things we need to handle, right? So I think that's enough for explanations. I'll try my best, right? So let's dive in coding. Okay, the first thing here is that we must check if there's a cycle starting at every number, register loop. So thinking of using a for loop here, let I use index I less than array dot length, a traditional for loop here. Okay, okay, bring it down here. So our goal here is our goal at each iterations is that we we're trying to check if there's a cycle uh, if there's a cycle in if there's a cycle starting at index I, right? And if there is, which means we have at least one, when return true for the whole functions. If no, we keep checking, and at the end, if we haven't run into the true, returning true here, it means there's not any there's no any cycle, so we just return false. Okay. Okay. Oh, there's a lot of informations here. So for checking cycle, I'm gonna use two pointers, right? So slow and fast. Slow and fast will be the index, right? Initially, it uh, points to the the current I. Slow will be I, fast will be I. Okay. Hmm. So here for checking the cycle, I may want to use another while loop here, right? At first, initially, I don't know when to stop yet, but let's give it true here, so that we can think of the stop condition later. Right? Okay, we go inside here, right? So I want to like just like every slow fast pointers problem. I want to move slow one step forward. Slow will be moving one step forward. Fast will be two step forward. But the logic of find the next index, I probably want to abstract it out into a functions that I can write later. So I could do something like next up, for example, right? We need to pass in what the current index, which is slow, right? This will determine the next index, right, of slow, and reassign to slow here, right? Same for fast. Next of fast, right? But for fast, I want to call it twice, right? So that it could go at double speed here, right? So after here, if it is the case that slow is equal to fast, it's gonna be gray, which means we have a circular, we have a cycle here. I could return choose for the whole functions. That is probably not enough here, right? Because and okay, but it is good for now, I think. So if we somehow reach the end here without jumping into this line, I'm return false. I probably need to have some kind of logic to uh, break from this while loop. Otherwise, it could go into infinite loop. Right? So we so for each we're checking if there's a loop, there's a cycle starting at each number, right? So if we here if slow meets fast, on return choose, but we have other cases as well, which is cycle should have more than one element, right? And should follow one directions. Hmm. How do we for this line, as we discussed earlier, we need to remember the current directions, right? So probably I want to remember at first, right? Here, I guess. So before start checking if the cycle starting at I want to remember the current directions, right? So I could let's call it east forward, for example, right? East forward when the current number, which is array at index I, is greater than 0. Okay. So at each, so here we find the next index here, right? We find the next index here. Then we could do something like if if array of slow, which is a new index, right, is let's say is still forward, is forward now, right? You could check by array of slow is greater than 0, right? So if is forward is different than is forward now, which means we have the cycle contains both forward and backward movements, right? So it means here we could break it right here. We break from this loop and exit here, coming back, checking the next eye, right? So if we do like this, we must do the same logics for this and this also. So it's kind of messy, I think. So one little trick here is that we can wrap up the logic, right, inside the next of functions, right? So let's say we expect the next of will return mm, the next uh, index, right? The next index for the current index, right? That is what we expect. But we can wrap the logics of checking the directions inside. So if we the current directions, um, let's say if the original directions is different than the current directions, right? Which can be checked by the next index, right? Then we can return -1 for these functions. Next up could return -1, right? So we could do something like, okay, if slow the next index is equal to -1, it means, I'm assuming that -1 means we're having an invalid here, right? Invalid value. It could be that because we have uh, it contains both forward and backward movements, or the cycle have one element, right? So -1 means invalid. We just break right here, right? And same here, if fast equal to -1, we just break right here, and we don't want to keep checking the cycle starting at current eye because we're sure that it's not invalid. Uh, it's not a valid cycle, and we want to keep checking the next eye. So again, here we could do something like this. Okay. So after each step, want to keep checking. You could see kind of repetitive here, but we could remove the first line, right? Because after the first here, slow moves forward one step, fast also move forward one step, right? We could check fast only, right? So you can save one operations here, one line of code here. So if because fast um, the fast pointer is going forward, right? It will um, if we are sure that fast is if we are sure that fast here is different than -1, then we are sure that slow is different than -1, right? Because here we break into 2 steps, right? Fast in 2 steps, just same as the slow, right? Okay, fast. Okay, it's been very long, so let's try to do it quick here. Okay, fast. If fast is equal to -1, it's invalid. I will break it. Next one, okay. But if it doesn't break here, we let fast move another step here. Again, check -1. If the current is valid, if the step, the movement is valid. Okay, if it doesn't break here, okay, we check if current slow equal to fast. If it is equal, it means we have a cycle here. We return true for the whole functions. Okay, it's very good, I think. So, because we decide to move the logics of checking these kind of things inside the next of functions, we must pass in is forward, which means the current directions is forward and is forward. So I will move the next up here inside this function so that we can have access to array here without passing in these functions. Next up, we have the curly next, right? We have is forward. Okay. So we must define the next index, right? That's next index. The next index would be the current index plus what? The value of the current index, right? Alright, idx. Okay. This is not enough because this could out of range. So we must modulo by array.length. Okay. So return next index at the end, but it is not enough because we want the logics. These two logics, right? So if the cycle have more than one element, so if the cycle has one element means the next index equal to the current index, right? Return -1. So we check. So if we return the next index is -1 here, we just break it right here. Keep checking the next I. And this line both forward and backward movements. So if so let's here is the original directions, so the current directions, let's call it is now forward. We could use the value of next index, right? Array of next index is greater than 0, right? So then we could check is forward is different than is now forward. If it's different, then it means we have both forward and backward movements. Return -1 here. Okay, so if it not, return the next unit. Okay, that is basically all we need to do, I think. So let's run the test. I think it will work. Okay, it works. Okay, it's been a long video, so thanks for watching. Right, that's it for cycle in circular array. See you in the next one.